Hi, everyone. Welcome to the Bartlett guest seminar series, Speculative Design, which discusses the meaning, impact, and applications of speculation in design. So this series is both interdisciplinary and intercultural. Every seminar, we invite guests from all over the world from different disciplines to discuss a sub-theme. So the format of the seminar is a roundtable, right? Where each of our guests is given the equal rights to give a pitch on their vision, after which they will debate around the central theme on their agreements and disagreements. But most importantly, please remember that the floor is open, so everyone is welcome to participate. Just jump in, raise your hand, type your questions, turn on your camera, scream, and stuff like that. Especially for students, this series is made for you. So this year has been a virtually difficult time, right? We wish to turn this difficulty into an opportunity for you. So to connect you with a global network of expertise and discourses, something that otherwise would have been quite difficult. Just like imagine bringing all these people from around the world into a physical room. So please don't be shy. You can challenge our guests with any questions or obstacles you're having in your projects. You're in the third semester or just general thoughts. Just take this precious chance to gain new perspectives. So today our topic is collaborative intelligence, and we have ourselves some very, very special guests, most of whom are working in creative fields that are outside architecture, but closely related to our built environment and the tools that actually intervene with it, including computer graphics, computer science, fine art, etc. So by inviting these interdisciplinary guests, we aim to inspire us alternative approaches to think about design, no matter architecture or urban. So design as processes of problem solving. And these leads to the background information on our topic, collaborative intelligence, which sounds magical, but actually we're already doing it almost because it denotes multi-agent distributed systems of humans and machines that contribute to a problem-solving network, right? So these networks include social networks like crowdsourcing ecosystem to aggregate individual expertise, preferences, and contributions. So this seminar, our four guests will discuss their experiences in the Creative Commons, the open source, the maker movement in their respective fields, and how the cross-stacking of information and intelligence contribute to their interdisciplinary speculative practices. So before we start, let me just introduce our guest, and then we can give them a warm welcome with some virtual claps. So our first guest is Joris Putteneers, who considers himself a speculative architect, blurring the boundaries between fiction and non-fiction architecture, mapping the post-Anthropocene through a non-human ontology. So he's actively working in his studio since 2017, which specialized in data-driven design, VR, AR technology, digital fabrication, concept design, art direction, and visualization. He is currently teaching at the BPro AD Cluster 1 and UD Cluster 19 and 20 at the Bartlett UCL. Also in the United States, Studio 317 Artificial Intelligence Studio. Our second guest is Yancy, aka Alexei. So he is an artist engineer from Moscow. He studied at the Robotics and Complex Automation Department of Moscow State Technical University. So Yancy is a member of the artist collective, AFSEX. I never know how to pronounce it.
Artist collectives, archive, and Alicha, and current team.
So, there it is. Pardon me for my lack of knowledge.
Imaginary art collective also.
Cool. Yeah, so it is a spatial temporal structure in a constant process of transformation. Yancy is also a lead animator in CGF Studio. Yeah, so last but not least, we have Farmer. Okay, Farmer. Last but not least, we have Artem Konevskikh, studied computer science.
I think at the end of my I will say about this transformation from lead animator to another field in the end of my speech.
Awesome. I think you have a slight internet problem, but we don't worry about it until later. So last but not least, we have Artem Konevskikh, who studied computer science at Moscow Institute of Radial Engineering and Automation, and then applied this knowledge in the field of experimental particle physics by developing data acquisition systems and doing data analysis for CERN, the Institute for Nuclear Research, RAS. So he's also one of the founders of the makerspace Physics Kunst Camera in Moscow, where he's teaching advanced technologies for the rapid prototyping and software development. So this brought him to Strauka to research the impact of new technologies to society, and results in his research experience in Atoll, a speculative platform which uses neural network for simulation of urban processes. Artem is currently working at the Strauka KP, where he is developing urban analysis tools, as well as collaborating in artistic and research projects on implementation of artificial intelligence and neural networks into design processes. Actually, we have a fourth guest who is having problems connecting today, but she'll show up in more static, less interactive virtual format. So she is Eli Joteva, a Bulgarian intermediate artist and researcher based in LA. So she has a practice rooted in photography and digital media, and is deeply influenced by contemporary research in the fields of quantum mechanics, neurophysics, and machine vision. So the core of her current research explores organic and computational memory systems in relation to image process of the past and future. So Eli is currently a curator for Super Collider Gallery in Los Angeles, and is an active member of UCLA Art and Science Lab since 2016. So without further ado, let us welcome our first guest, Joris. Applause.
Hey guys, hello, good afternoon, good morning. Yeah, so thank you for the introduction. Yeah, we'll just get started, I guess. Maybe let me share my screen, and then we can start. All right, so as Provide said, my name is Joris Putteneers. I co-teach RC20, RC1, and RC19 at the Bartlett. And before I start with the presentation of my personal projects, I would like to introduce a little bit of conceptual framework to, so you guys have like a framework where I work in. We are currently living in a very interesting time, I think. Like AI and machine learning networks are kind of all over the place. We're kind of engulfed in it. And we're kind of slowly learning that if we let those computers or machines solve the problems in their own kind of way, maybe like a post-scientific kind of way, sometimes they do it better and faster. And we are okay with that, and I think that's great. And my research mainly investigates what kind of anomalies or artifacts that are coming from that kind of black box algorithmic approach, which I found very fascinating. So the artifacts that are being generated by these AIs, by these machine learning networks, they kind of give us an insight in how these things work. For me, I think that's very interesting. So I'm going to go over some personal projects first. One of them is synesthesia. It's an algorithm I developed that kind of uses input parameters such as room surface, room volume, circulation, distribution, density, and proximity to generate this kind of agent-based systems. And of course, I designed this algorithm myself, and it gives, I know how it works, but because it works for one, but it works for like 10,000 of those, right? So for me, the fascination lies in all the recursive errors and the artifacts that are kind of emerging through this process that, for me, wouldn't otherwise be possible if you would make this by yourself, by hand, for example. So for me, this was all experiments, all the same algorithm, but every time using different input parameters. For me, it's interesting because it lies somewhere between like organic and inorganic some like artificial and natural. For me, that's really fascinating. All these models are not post-processed, so they are straight from the algorithm. It's also interesting because they have no idea about existing architecture, or they have no context to work in. So that's what makes them, for me, quite fascinating. In another iteration, I tried to kind of support those algorithms by implementing some hard surface models. It's very interesting to see how the algorithm itself reacts to these things, and you get these kind of I don't know, like soft and hard variations, which I found interesting. Also, if you like, it also, for me, it interests like the detail of how these things are being visualized and communicated. For me, I always think then, how would, for example, a post-anthropocentric detail be visualized if it was not be for, let's say, like structural or building segments or something. The same goes for this project, Nano. It was more of a kind of a cinematic project where I tried to investigate these with a little bit more context. If you want to, there are also some YouTube videos online if you want to watch them. These were post-processed a little bit afterwards, but mainly it's the result of the algorithm. And then for the schizoid project, this was basically using the same, but now for more of an, I would say, an architectural purpose, as it was for like a biologist or a botanist that had a couple of parameters revolving the room temperature and the natural ventilation. So the algorithm generated these kind of shapes, but for me it's interesting because it also created these sections, which makes it for me a little bit more architectural. And then also an iteration on hard surface models, how those can be implemented. And for me, the really fascinating thing is every time you let the algorithm run with different parameters, you investigate or you see something new, and that's what interests me a lot. It's always, I mean, it's like you find those structures where, yeah, for me that's super interesting. It's like you're investigating a new island or something totally alien, with some interior shots as well. And then the same procedure goes for the Protozoa project, where I started slowly to integrate a little bit more other tools such as VR and some game engines, but that's something we'll discuss later. And then for the Aerolis project, it was a multidisciplinary project between me and bioengineers and mathematicians, where we had the task of filtrating the bad air pollutants from like a part of the city. And we did this by having this very, multidisciplinary approach, where the mathematician sometimes would be the architect and I would be sometimes, or try to be the bioengineer, and we would kind of, I would approach some standpoint from an architectural perspective, and vice versa. And that what made this project really, really fun to work with. The bioengineer side, they wanted to introduce biotin, or kind of a modified version of vitamin B into polylactic acid, so PLE, so the material you would normally print with, 3D print with. So we developed first some concept sketches. It kind of depicted the idea, what we wanted to do, but later it developed to be more of this kind of approach. Some more images. There are also 2 videos online where we discuss the technical project, the technical part, but also more the cinematic part. We also had the opportunity to present this at the MoMA in New York, which was really nice. It was my first time in New York as well, which was great. And then over here you see the white 3D printed model that actually contained the that was actually printed with the biotin infused PLA, which was quite a hassle to import to the US as GMOs. I mean, it's difficult to import GMOs into the US. So, but, yeah, and we also made like a VR installation. And maybe also coming back to VR. I mean, the tool sets I use, they vary a lot. One of them being working inside of a virtual reality environment. I think it once was a gimmick, but now I think it's super, super important for me at least. Once you are working in a more traditional software package, you are kind of limited to like a fraction of your screen space because you have your modifiers and your menus and all the other settings. Whilst in VR, you are kind of free of all those distractions, and it's like just you and your two hands and your two handles, and you can kind of git bash and create whatever you want, which for me is a very freeing process, I think. Also, the element of scale is very important. It also helps to gain new perspectives in how you would tackle such projects. And maybe something else, but the way I think about speculative design is actually mostly by doing, I think. Mainly all my experiments, they have a kind of a basic question, and I start developing those in VR or in another software package. And then slowly they can give a response to something that I'm researching. So the same goes for here. It's all in virtual reality models and also rendered in Eevee in Blender. So it's real time, which also allows for very, very quick prototyping. Yeah. Also had the opportunity to teach these kind of procedures now at the Bartlett, but previously at Texas A&M. And one being a project called Autopoietic Morphologies. It's basically a kind of an architectural prototype that reacts to the basic soil composition. If, for example, the soil would contain lithium, it would react totally different than would it contain a large amount of iron, for example. Oops. Oh, yeah. So these are some examples of 3D printed models. It was a really fun studio because as these algorithms were mostly considered like a black box, it was kind of hard to see what was really going on the inside. But the students, I think, I mean, they really enjoyed it because every time they changed the parameters, there was another setting that drastically changed. And at the end of the time, they really started to understand how and why certain things were happening and kind of embracing those artifacts, which I think was really great. And the whole studio covered, I mean, a lot of tools, VR, programming, and that is the wonderful thing about it as well. It's like once, I mean, I used to, like a long time ago, when I was also interested in these kind of topics, I was using the very basic modeling tools, such as architectural modeling tools, such as SketchUp or AutoCAD. But very, very quickly, I think I began to see what kind of limitations they had if we really wanted to develop this work. Not per se formally, but as in a way of formally expressing your concept, but also if you work in very basic modeling packages, you start to think of, I mean, the constraints and the restrictions, they start to influence your modeling or your project. And I'm not saying that those are not good, but it's like when you are drawing on a piece of paper, you can draw whatever you want, basically, and it should not be any different in a 3D software package. or I think so at least. Yeah, so these were now some screenshots, also investigating the architectural detail of these kind of more post-anthropocentric studios, which was really great, I think. Yeah, and also, like I said before, once they were like investigating the outputs, they started to see all kind of artifacts and anomalies in the whole process, which kind of made the black box readable in a sense, which think it was great. And we also had some experiments how we can materialize these kind of structures. So we went, for example, to the scrapyard, and we just took car parts, took some parts lying around. We 3D printed some parts, and quickly in the course of 2 or 3 days, we just made these these monstrosities, which was great, I think. Also, last year we did a 15-day workshop at the Bartlett, which also encompasses these all algorithmic procedures, and it was a really wonderful workshop because also the students were really enthusiastic about the whole procedure, and also investigating the new typologies that can emerge from these kind of approaches, which was wonderful. And then for my last project, it was my master thesis, was finished last year. It's called Ugly, Stupid, Honest, and it's basically a critical response to I would say, for today's purposes, but what I mostly see is in the context of artificial intelligence and machine learning, they're mostly kind of used, or some of them are used to kind of, I would say, delete the human artifact or delete the human errors or mistakes from certain procedures, I think. And this kind of has like a critical view on why AI and machine learning should kind of embrace these kind of procedures, why it should embrace these human mistakes. So I built a robot that basically does 2 things. For one, it tries to find its way home using very basic tools, such as speedometer and all that stuff. It tries to go to a specific coordinates, which was my home at the time. And then at the same time, it tries to map that journey. So it comes across, this is just an overview of the meters. But it comes across certain things like people, objects, bikes, and it detects and classifies them. And using all that, but I walked with that robot for about 110 kilometers. So all that data was gathered, and at the end of the week of walking, there was some kind of output. So it from all the data set, it tried to reconfigure what a car would be like, or what a bike would be like. As you can see, it's very kind of riddled with glitches, which is great, I think. And this is like an overview of the robot. Yeah, thank you very much. This was my short presentation.
Thank you so much. Very interesting, ugly, honest, stupid. I think you would for sure also have a conversation around the same manner. Anyway, before we jump into that, let's welcome our second guest, Yancy. Yancito-san, lovely.
Hello, everybody.
Konnichiwa.
Let's try to share my screen.
Ooh, hello.
Yeah, let me... Hello, everybody. Thank you for watching and hearing. First of all, I think it's better to introduce myself, and partially my talk would be around this topic, like yourself, who you actually are, and how to like understand. If we're talking about collaborative intelligence, yeah, it's a system where the agents, like people or not people, interacting, yeah. But in this system is important to understand what's your role as a like input and output, like how to determine this entity as yourself. So I'm, first of all, I think I'm an artist, and then I'm an CG artist, and then I'm speculative artist, contemporary artist, engineer artist, and so on. But still, it's hard to understand exactly and say who you are nowadays, because everything is merging, and the world is super dynamic right now. So, as you may know, we meet each other, like provides Artem, Eli. We met each other at Strelka Institute, and it was 2 years ago. And I don't know, maybe first of all, I want to show you the video, self-introduction video I sent to Strelka to get into that program. And maybe you can understand more about me, or maybe less. Let's see.
There are no sound. I think you have to stop share, reshare, and then press share sound.
Oh, whoa.
Yeah. Yes, engineer, please. Get your Zoom working. Share, but remember to press share sound.
I see. Yeah, okay.
Yes, thank you, engineer.
Artist. You see an artist.
Yeah, you press. Yep.
Working?
Hello, Strelka. My name is Yanzi, and welcome to the fabulous world of my skills, abilities, and aspirations. Don't have a lot of time, so let's check me out. Here is our engineering department. Hello. Could you please say something? Hello. Yeah. Okay, thanks. That's enough. That's enough. Next one is Artistic Corner in 2010. Nice installation. And what's the head is about? The head is about thinking on modern world issues, buddy. Okay, and what's the price? Priceless. Thanks. Okay, maybe I come later on. Yeah. So now we are moving to our main attraction. Is a place where all the magic happens. Here you can find all kinds of 3D graphics, motion graphics, simulations, animations. Man, cool collection. Yeah. Virtual reality, augmented reality, and even unreality reality could be found here. And the next one is a music experimentational unit. I don't know, is it useful for you or not, but never mind. And as a bonus, you can get even this skateboarder guy on the background. This is all for you, Strelka. and if you're interested, you can get it for just 39,200 rubles per month, and I'm making you a great discount because I think that Strelka is a unique place for gathering all that to make something big, fresh, and new normal. Thank you for watching. I hope you will make the right decision. Bye.
Sorry, Yancy, just want to make sure that before you play your next video, have you click optimize for videos?
Is also on that screen,
Yes.
but I think it's all for videos. Maybe
Just make
it's
sure you
not a
click
problem.
both share sound and optimize for video. But
So stop share.
yes, reshare, optimize for video, share sound. But by the way, that camera tracking was so on point.
So what?
On point.
Oh, I see. Yeah.
Yep. Thank you.
Sorry. So yeah, with that video and portfolio made like partially from projects that never existed, I came to Strelka, and I think I want to talk today about speculative self, because when it comes to like speculative design, you are who designs something, yeah, but you can also apply these principles to yourself, and I can elaborate on that more, like why we have to do this nowadays is because, for example, we come into Strelka and Strelka is a think tank where you're working in like random groups of people having different expertise. And these small groups are solving some problems or making some presentations and trying to imagine how the future may look like. But Strelka treats you as a like solid entity, like you 3D artist, yeah. So you in this group supposed to like make something in 3D, but this approach, I think, especially now 2 years later, it's like little bit old school, I think, because I noticed that you can less and less you can't master something nowadays because we are living in an era of constant update. Because you as a professional, always you're mastering some tool, yeah, and right now tools updating at like each month or each week, or you can check your iPhone and see that each of the applications just wanted you to update them, and everything is changed. And if I was modeling, for example, like 5 years ago, all the approaches I know changed now. So it's just, I think, impossible to be a complete professional, and it's too solid structure for today's situation, because you see, yeah, even like, for example, like Joris, he's working with with tools that not existed like 5 years ago. Yeah, it's these tools just appearing in the real time, and you try to use them and apply for your situations. And of course, it's a completely different mindset because you're not thinking from the tools that already exist. Because this way you're gonna be in the past, like making something for the past, and you have to be 2 steps ahead for making something for now. And yeah, my point would be that we should change paradigm for learning, for interacting, and for collaboration, yeah, and how you perceive each other in collaboration. Because what I saw at Strelka, it's not really was like they supposed to be. Like not every time guys who was making like design were taking a role of designer in the team. Yeah, it was not so easy, at least like alchemy of working. Yeah, and another point I wanted to plug to these constructions, that the way how you think is not something like something unconstrained, like super free. It's always come from the tools you use. For example, when Rhino and their NURB surfaces approach appeared, you started to see the architecture, like these NURB surfaces, like Zaha Hadid and so on. And this is the tool speaking from you. Yeah, you're using the tool, and according to the tool, you can imagine the structure you can build. And yeah, and if we come back to Joris' lecture, you also can see this, yeah, because the tool invented by himself is also dictates how the final project will look like, and this is interesting feedback loop, like semi self referencing, but still expanding. And this also comes to like why speculative design becoming more and more popular and more widespread is let's see that speculative in Russian is умозрительный. Uma is for mind, and зрительный is for visual. So this you can try to make a step forward and imagine a construction like concept and visualization, and visualization tools is really fastly progressing now, and right now they're on the stage where most of the time is you can barely understand what is real and what is just rendered, and this is making this speculative approach work 100 times more efficient, because we're living in a visual culture, and if you see something, you can believe in it, yeah, and it's making and because people believe in the things, the things becoming real. Even at the starting point, they were not real or not existing. Yeah, you just showing them, showing like, look, this is here. Yeah, you see how it looks like. Everybody's synchronized to the same visual appearance, and it's not a question because, for example, Instagram. If you see something on Instagram, it's becoming like real for you. Yeah, because you see visual evidence of it, and what is in terms of what is real, I can make an example like money. Money is something totally not real, but everybody believes in it, and they make it our reality. Like the whole reality around us made by money, and money is just belief. So if you believe in something, it will make your reality like sometime later. And this is how hyperstition work. So if, and I can make an example of hyperstition, how hyperstition work. If somebody don't know what hyperstition is, there is a film called Hyperstition. It's 2015 released, and yeah, it's hyperstition.org. You can see it for $5, and guys there trying to explain the situation we live right now with for example, one of the things is how science fiction works. Like some science fiction writings made in 60s, where writers and scientists trying to imagine their future. They were just fantasizing about how it would look like, wrote it in the text, and lots of people have read that, and this is producing a hype, and hype producing this belief of like widespread belief of people that, yeah, we need flying skateboards, or we need self-drying code. Yeah, and after several years, some brands taking this idea and making a real code for that, and they making flying skateboards. As you remember, there was some internet meme about that. So from hype to reality, there is a really shortcut, like to to make it real. And yeah, that's why we're living right now in not in reality, we live in hyper reality. And according to in semiotics and postmodernism, hyperreality is an inability of consciousness to distinguish reality from a simulation of reality, especially in technologically advanced postmodern societies. And according to Baudrillard, he defined hyperreality as the generation by models of a real without origin of reality. It's a representation, a sign without an original referent. And right now, I left my job at CG company, which also was working on the hyper real state of world, because we were building something that not exist and make it believable, like films with 3D characters and so on. And now I'm working, started to work at digital humans field, and this is really really matches this last quote from Baudrillard, because these digital humans, they have no reference to the original referent. Yeah, they just started from sign, not from origin of the sign. They have no reference to something real. They started as unreal persons. And this is really emergent field right now. It's like big explosions of that, because companies want to have their promoters, their faces, their ambassadors who never feel like depression. They can work at night, at day. They can work 365 days a year, and yeah, they just calculated from some neural networks, some CG graphics, and they lack of these problems that ordinary people have. Like people got old, yeah, you know, and this is bad for the brands, because they have to change their faces, or these faces cost them a lot of money, but it's the way easier to just have some like algorithm. You just pick the video you want to change the face in, and then you get new advertising. So yeah, I wanted to bring these themes to the table. Hope it was not very messy, but I think you got the overall structure of what I wanted to say. Thank you.
Thank you so much. Whoa, that was impressively philosophical and so meta. I didn't expect that, but I love it. I think for sure we would have a lot of stuff to discuss around meta-human and speculative self. Interesting. But before that, let us welcome Artem.
Yeah, hello. Yeah, I will also share the screen. What optimize for web for video? Yeah, and share sound. Okay. So yeah, like Provide said, I'm working as a data scientist, and I used to work at CERN at particle physics, and then switched to some more human scale problems like urban data analysis. But I also collaborate with artists, especially on the topic of artificial intelligence and how it can be implemented in the artworks. So today I will talk more from artist perspective, and I will talk about artificial intelligence and speculative history. I don't know if you watched previous talks with Gleb, Lisa, and Valdis, but they discuss speculative design like something connected to the future, like how we can imagine the future, how we can predict something, prevent something, and so on. But in the project I was involved in, we discuss some really important questions more from the perspective of the past. We refer to some historical moments, and by imagining how it can develop in different ways, we are trying to analyze what's happening now, what are problems now. So I will show 3 projects that I made in collaboration with different people, and tried to explain my point of view a little bit. And we will start from the real ancient times, like several centuries before Christ. And it's a project called Content-Aware Studies, which we're doing with Igor Kraft. It's a project where we trying to reconstruct antique statues with the help of neural networks like style guns and some other neural network that can work with 3D models. And on the first sight, it can it looks like we just reconstructing the old statues that are now just to make them look pretty again. But as we know, neural networks doesn't work really great, and it has its own, let's say so, they has its own vision on some topics, like they then can judge about something only through the lens of the data set that was provided. And this is why the statue that is generated by the neural network is look different from the original one, from the one that human can make. And in this project, we discuss how, this topic of AI bias. Is it okay to give all the responsibility for reconstruction of some historical monuments, some historical artifacts like statues, like books and documents, or we still have to control this process and lead it in like with the human, like we should make this collaboration between human and artificial intelligence. And another topic that we discuss here is the new materiality, the materiality of digital arts, like those hats, they are built in a physical world, and you can touch it, you can look at it, but it made like only with digital instruments, like the 3D model was built with the help of neural networks, and then the marble was cut with CNC machines, and the pieces that was reconstructed by neural network was 3D printed. So it's almost a digital process without human in a loop. And of course, there is some preparation has to be made with the help of the human, but it also can be automated in some, if we spend some time. Yeah, but anyway, the process is very digital, but still it has a lot of physical aspects, like the neural network is not running in some abstract cloud or abstract anything, but it runs on the physical computer, and it use the real like physical resources to produce this digital art. So the next project, Neuro House, was built with the kids from Science Art Lab of Moscow Schools of Art. I gave I led the workshop on neural networks in arts last autumn, And our project was this beautiful house where each student had its own room where they tried to question some historical moments of of Russia, from the religion to the culture, from the communism to the collective memories of this communism times and so on. And I really like this project because the questions that kids were asking and that they wanted to represent in their artworks had the real resonance, even before we published this project to the public. We had some issues with censorship because our curators saw something like some issues, like we wanted to say something against our dear president and so on, but we didn't try to. We just imagine some possible scenarios from the past. Yeah, and my favorite, I will share the link to this Mozilla Hubs, and you can explore the building. And my favorite project from there is this room with the carpet you can see on the screen. It's the room that represents the common memory of the not memory, common thought of Russian apartment, Russian flat. And it's very interesting that even Soviet Union was disappeared like 30 years ago. All the attributes in the room, all the furniture and this carpet and the television is like still actual. And if someone in Russia say something like, what is your room look like what is the average flat look like, everyone will say, we have carpet, or we have this television in front of a main object in the room, and so on. And also I like this project is because this I don't know, the ghost of Soviet Union is still living in this room. And the project is made by the girl who is like 13 years old, and she put there some small details that I don't know where, how she knows about this, because she never lived in these times. And I don't know, I just like it, how it represents the time that happens now and the time that happens during this period when Soviet Union was disappearing, and we had this strange times when we get new motherland and so on. And yeah, and another, well, I think it's better to look to another project and read the description there, because I can talk a lot about this. And yeah, the next project is also done by my students, this time without any help from myself and my colleagues. It discusses the memory and machine memory, and it uses two neural networks, the GPT which is a neural network that works with text and build language models. And it was trained on recent news of events that happened in Russia, and then generate new like fake news, machine-generated news. And also it is illustrated by the style gun trained on images from the protests that happened at the time when guys were making this project. And they discuss, I'll show the video and then describe it. Yeah, so.
Но негативная активность беспрецедентная и примкнувшие к ним локальные инвесторы. Телевизор захлебывается от восторга, меря пресечения в кризис нефтяной полотежной на этой главной
Yeah, this is made like TV news, and actually it says some kind of nonsense, bullshit, and no real event is described. But the purpose of this project is to ask what is memory. Is it like exact fact that was happened, or is it just a perception of this event and the way how people think of it, and can machine think of the event that happened, or it can somehow get another point of view on the event that was there, like does it represent it in the same way it was happening, or it can have its own point of view. Yeah, so it's like I think it's all I wanted to show and to say. So if you want to follow me, it's how you can find me everywhere on social networks. Yeah. Yeah. Thank you.
Thank you, Artem. Okay, we have some comments saying it's super advanced thinking. Anyway, so before we jump into the roundtable, we will also hear from Eli Joteva, and then we will begin the conversation.
Thank you so much for inviting me. I'm so excited to be here and to share with all of you what I've been up to since USC. My work over the last few years definitely has taken many multidisciplinary approaches, and I definitely have USC to thank for that, because the BA program was so interdisciplinary and allowed me to think outside of the box and take different classes. So it influences my work to this day. I still geek out on quantum physics and different types of imaging technologies. So yeah, as an artist working with scientific research and data, I found that my role is to use my imagination to make connections between seemingly unrelated things and find ways to ask the right questions, and most importantly, inspire a sense of awe and wonder in the viewer, which I think is especially important in these times of collective fear that we've been experiencing over the last year. I'm going to start off with a throwback to 10 years ago that Jay was mentioned in the intro. This is my first installation that was at Lyndhurst, and it was made with suspended paper bark tree that I used as projection screens. And I'm super glad that you asked me to find this photo in my archives, because it made me realize that my fascination with collecting organic materials, suspending them, and projecting onto them really started at USC while I was in your class. Thank you for your inspiring mentorship and influence over these years. But this was also a time when I started thinking about how time is held and distributed through the light of an image. And I projected the same video piece from two ends of this installation, one forwards in time and one backwards in time, because I was thinking about how they could meet in the sort of space-time point in the middle. And then to jump forward 5 years later, in my first solo show in grad school, where I continued to explore this idea of the suspended organic form and entropy, but more through the prism of memory and how memory is held within matter, how it's digitally archived, and the kind of connection between these two spaces. So the show was split into 4 sections. Each was centered around remembering either the past, present, or future, and then the space in between. And the kind of star of this show were these 3 cryo sculptures made of organic materials frozen in water. I actually had to buy a really big freezer to make them. They're about 40 centimeters in diameter and pretty heavy. And they function like landscape portraits with natural elements from different ecological sites frozen inside of them. Like the first one is made from wildflowers and sand from the desert. The middle one is from a gardenia bush in the backyard, in my backyard in K-Town. And the right one is from imported Chinese mushrooms. And over the course of these 3 days of the 3-day exhibition, they kind of slowly performed this cycle of unraveling their interior contents and releasing them into the gallery space. Because they were changing so slowly, viewers would often come back multiple times over the day to just see how much they've changed. So now I'm going to show you a short video documentation of it. And the title Nemoawari comes from a mix of the Greek goddess of memory Mnemosyne and the Japanese word mono no aware, which translates to the beauty found in the sadness of a fleeting moment. So the sound is coming from this sculpture where I had a contact mic that would amplify each drop. As a kind of entropy clock, making the viewer hyper aware of time passing by and the materials changing. And scale and the relationship of the objects to the body became a really important way for me to negate a kind of psychosomatic experience for the viewer. There was a very strong sense of smell that came from every sculpture. Each sphere has its own would target the senses in a different way as they would break down. I think at the time I was watching a lot of videos of the ice caps melting and reflecting on my feelings about the ecological crisis and my inability as a single human to really do anything about it. So I considered the containers underneath as these sort of futile human gestures that of trying to interfere with ecological cycles. Like on the one hand, working with the desire to contain processes larger than us, while at the same time honoring the power which entropy affords towards evolution. I was thinking a lot about thermodynamics and that the higher the heat, the more chaos, the more possibilities for new combinations and potentials. And then on the digital side, each sculpture was 3D scanned as it came out of the freezer and projected on a large scale in another part of the gallery, which is what you see on the right in this image. This is another pair of the physical object on the right and the scan on the left. And having them side by side in the space really allowed me to amplify the micro material of the present into a kind of planetary scale archive record. And I've been drawn to photography as a tool for preserving the fleeting material reality for a really long time. But this is the first time I worked with photogrammetry, which is the process of creating a 3D model from hundreds of images of an object from all different angles. And ice is actually really hard to scan because it's reflective and reflections end up throwing off the algorithms of the software, but I ended up finding a solution. And finally, it was really important for me to make a real-time connection between the digital model and the fleeting physical object. So I had a VR piece where you could enter inside one of the 3D scanned spheres that was still rotating around you with the audio component feeding in real time and kind of glitching the piece, glitching the image with every drip. So I continued to make these organic sphere-shaped sculptures that would change through time. This is a short time-lapse video of one of them deteriorating over the course of 3 days. It's layered with a partial 3D scan, and it's made with moss, soil, and wood chips. I actually don't think I have time to show you the full video, but it's awesome and you should watch it online. And then later that year, I did a residency in Thailand where I worked with a team of students at the Silpakorn University to build this organic sculpture with a hacked camera inside, whose trigger was controlled by moisture and light sensors. We were kind of trying to ask the question, if the Earth could see, what would it be? So we wanted to make this Earth-controlled camera. And I wove the structure out of local fauna, and it was exhibited at the Mocha Bangkok Museum. In the middle image to the right, you can see the photo that the camera took. And after the show came down, we decided to set it on fire so we can just watch it undergo another entropic cycle of change. Right before the pandemic hit last year, I had the opportunity to make 3 more ice spheres for the Spring Break Art Fair in LA. And I look back on this show with a lot of fondness because it was the last IRL show before the lockdowns happened, with an amazing set of artists from Super Collider and Fembit. It was a 3-day event in which I showed 0 Point Field. It's a light piece that I'm going to talk about a little bit later. And I made a new sphere each day. The first one was a bit more experimental, and it had this big crash and splash and melt towards the end of the last day, which I actually loved, to sort of bring this chaos and entropy into that space, especially for that fair. The second one is my favorite. It was made of spring blooms, electrical wire, and electronic components. This one evolved quite nicely, I think. And the last one was predominantly made with soil and electrical wire.
Isn't it cool? So everything's inside the ice and it's slowly melting and losing.
I love that little girl. She was really cute. So later in the summer of 2020, I was living in Altadena, which was right next to the Bobcat fire. So I kind of felt like we were living in Mordor for a few weeks. Those of you in LA maybe remember it. And this video was made as a response to that. The sphere is made from coals, ash, and seeds and blooms from Altadena. And the vibrant blue actually comes from a special spirulina that facilitates seed growth. I definitely started doing this time lapse as the fires were burning 10 miles away from me, as a sort of ode to the necessity of entropy in larger than human cycles. And then in the fall of that year, I started grad school. I chose DMA at UCLA mainly because of the Art Sci Center and Lab Collective, which is interdisciplinary collective that I have been a part of since then. And I really wanted to work with biofeedback data, partially because I had experienced it in a therapeutic setting, and I found it incredibly effective and fascinating technology for mirroring these invisible internal states and building new neural pathways. So in my first semester, I built a custom software that translated each band of electrical brainwave activity to its corresponding color harmonic frequency. For example, I mapped the delta signals of red because the delta signals to red because they're both low frequencies, or the gamma to blue because they vibrate faster. And in this pixel stream that you see on the bottom left, my brainwaves would generate a different color for the predominant wave at every millisecond. So I recorded my activity, my brainwave activity during different states of mind, which I would then project onto blocks of ice to create brainwave portraits. And for my first crit, I presented a real-time projection mapping of each brainwave band onto telepathic different sections of ice. And I tried this telepathic performance. And on the walls, I had 4 videos of brainwave data recorded during various states where different activities would either simulate larger theta, gamma, alpha, or beta. And then using the same prototype tool, I began making a series of brainwave portraits that reveal internal states. So this is looking at 3 variations of recalling the same dream over the same block of ice. I would record my brainwaves during different activities like petting a cat, watching the election, or kissing someone. And I was also thinking a lot about the material memory of the frozen water. And I wanted to see if the structures would be altered by subtle energies and of the bodies that hold them. So when I started doing portraits for my friends, I would ask them to hold a bottle close to their bodies and maybe even sleep with it before freezing it to see if that would change the structure when I would project their waves onto them. This is another portrait in which I had it for my solo show as an entrance, as a kind of memory of the future. I was thinking about the act of recalling a dream and how dreams can actually be predictive of the future. And I have a lot of them. So around this time, I got introduced to Mayank Mehta, who runs the neurophysics lab at UCLA, where they study how memory forms in rats. And this was super fascinating to me because they literally place these rats in VR environments and stick electrodes into their hippocampus to measure how memory forms in their brains. So they have them running around, and they found that gamma and theta waves, the coupling of gamma and theta waves, is actually what's needed for a memory synapse to form. So I found this super interesting, that the sort of high vibrating genius gamma wave, which is experienced in moments of creativity, needs the deep unconscious theta wave that's experienced during deep sleep to synchronize neuron spikes. And working off of that, I built a prototype that isolates only those two bands and could give me a real-time color in real time on top of the band. So orange for theta and purple for gamma when one is more dominant. And then I used this prop as a tool for a series of performances. This was actually like the first time that I was able to take some scientific findings and make a poetic interpretation of them, thinking a lot about how neural light can be used to delineate an emergent memory of the body. So what you're looking at is documentation of me trying to climb a tree that I remember very well in my dad's backyard with my eyes closed while wearing this hacked brainwave band. And it's streaming my activity in real time. So anytime you see yellow, the theta wave is predominant. And anytime you see purple, the gamma wave is predominant. I'm also going to be teaching it at Houdini School, which launches soon. This is one of my recent render experiments that I minted as an NFT on the eco-friendly Hiketnung site. And they're meant to be different types of memories. I'm also playing around with placing it in AR and being able to experience it in different landscapes. I'm also using Houdini to process some MRI scans of my own body for an art and science residency that I started with Fraunhofer Mewis at Ars Electronica last year. And in this residency, I was really interested in finding what is not measurable in medical imaging, and to locate the limits of perception and how the very act of producing an image shapes our imaginations. But the residency itself was super fascinating. Over the course of a month, I worked really closely with scientists from Fraunhofer to explore the limits of and the boundaries of imaging and 3D modeling and predictive modeling. I also had a chance to do a full body MRI scans at USC Loney. I'm still working on processing the data, but the back end is really fascinating to me. I don't think I have time to get into it, the math, but there's something that was really cool about I was drawn to these light colored images, the DTI scans, which is diffusion tensor imaging. It's a kind of indirect measurement of brain fibers. And what I found out during the residency is that those images don't actually map the fibers, they map the movement of hydrogen atoms along the axons. So I'm working with the data in Houdini to bring the molecules that are missing from the data back in with these render tests. So here are some in progress tests. And I'm trying to see if it's possible to get these fibers from other parts of the body, which scientists tend not to do because the body moves. The brain is easy to scan, but the body moves, and the scans take about 10 minutes to do. And I'm also asking the question if it's possible to locate exactly where memory is held in the body through maybe resting state whole body imaging, which is also something that's never been done. So the results are still pending, and the final project will be presented at Ars Electronica this year. And then some final words on collective projects that I've done in the last few years. After grad school, I was a fellow at the post-grad research program, Strelka the New Normal, where I completed multiple speculative film projects, including Current, which is a film on the future of broadcasting cinema. And it's been shown in multiple festivals and conferences over the last few years. It sits at the intersection of live stream, personalized attention economies, and volumetric cinema, and some AI optimization. But this scene in particular is one of my favorite because we're thinking about endangered sites and how they can be reconstructed volumetrically in the future. And I'm still working on the project today with the Current team. We have a couple of different virtual reality reconstructed events happening this year. So I welcome you to check us out at current.cam. We're going to be doing some fun stuff later this year, and you can also explore the VR gallery on the website, which I built. And then speaking of VR galleries, last year I also worked as a co-curator and virtual director for the Phenomenology of Hope show, where we presented one of the first VR exhibitions during the pandemic with over 40 different artists. I co-curated it with Keo Griffith and Kang Yugen and directed the production of the VR gallery with a team of incredible interns from Drexel University. It was a huge endeavor and it took us 3 months to do, but it totally kept us sane during the difficult times last year. And it was really exciting to be able to see people in that space and meet them and talk to them in your avatar self. So you can actually still check out the show at phenomenologyofhope.com. And I think that's it. I'm kind of on time, right? We have time for questions. I'm going to stop sharing now.
Cool. Oh, feedback loop. Okay, so thank you for all of our guests who have presented. So right now, as a little tradition, I would read a small paragraph to start the roundtable. And actually, before we started the section, I was going to read from The Strange Loop from Hofstadter, but then I've changed my mind again. So I'm actually going to read from Possible Minds. So this book is hard to get a PDF online. You have to get a physical book because of how fresh this book is from 25 scientists who are actually working in the field of AI and who are like really experienced. So this small paragraph that I'm going to read from, it's called The Unity of Intelligence, which I think is pretty relevant to our topic today. And it's from Professor Frank Wilczek. I hope I pronounced his name right. So he is a Nobel Prize physicist at the MIT. And here's what he is saying about the unity of intelligence. So evidently, as platforms for intelligence, human brains are far from optimal. Still, although versatile housekeeping robots or mechanical soldiers would find ready, lucrative markets, at present, there is no machine that approaches the kind of general purpose human intelligence those applications would require. So despite their relative weakness on many fronts, human brains have big advantages over their artificial competitors. So he mentioned 5, but I will only talk about 3 of them because I think that's more relevant to our topics today. So the first one is about 3D, three-dimensionality. Although as noted, the linear dimension of existing artificial processing units are vastly smaller than those of brains, and procedure by which they're made centered on lithography. So it's essentially 2-dimensional. So that is revealed visibly in the geometry of computer boards and chips. Of course, one can stack boards like how we used to stack pixels, but the spacing between layers is much larger and communication much less efficient than within the layers. So brains make better use of 3 dimensions. Second point is connectivity. So human neurons typically support several hundred connections, synapses. Moreover, the complex pattern of these connections is very meaningful. So computer units typically only make a handful of connections in regular fixed patterns. Last but not least, integration of sensors and actuators. So the human brain comes equipped with a variety of sensory organs, notably including its outgrowth eyes and with versatile actuators. That's interesting. I've never imagined our eyes growing inside our head. But anyway, including hands and that build, legs that walk, and mouths that speak. So these sensors and actuators are seamlessly integrated into the brain's information processing centers, having been honed over millions of years of natural selection. We interpret their raw signals and control their large-scale actions with minimal conscious attention. So the flip side is that we don't know how we actually do this, and the implementation is opaque. It's proving surprisingly difficult to reach human standards on these routine input-output functions. So he continued to saying that these advantages of human brains over currently engineering artifacts are profound. So human brains supply an inspiring existence proof, showing us several ways we can get out of matter. So what if our engineering actually catch up? So we're not scientists, so we're going to talk about this in terms of speculative design. And I'll try to narrow this question not a collaboration between humans, but maybe collaboration between our tools, which I think all of your talks overlaps. It's talking about the digital tools that we actually use. So the future of intelligent tools, which is the same time the future of design production. So how would you think the collaboration between tools would be before we actually talk about the humans? That was the question. What do you think is the future of collaborative intelligence between the tools that we use, and how would it change our design production?